What if Earth's core froze today? The Silent Cataclysm begins. Have you ever wondered what would happen if the very heart of our planet, its churning molten core, suddenly froze solid? It's a thought experiment that delves into the profound fragility of our existence, revealing the hidden power that sustains life as we know it. Today we're going to explore that impossible scenario, scene by terrifying scene. Imagine a world where the humming, churning core of our planet suddenly stops. No grand explosion, no immediate cataclysm. Instead, a quiet, profound change in Earth's deepest engine, akin to the geological stillness of an exoplanet like Kepler 186f, which likely has a non-convecting core. The very first sign we'd notice wouldn't be a grand explosion, but an almost imperceptible shift, a quiet tremor deep within, a hint of something profoundly wrong in the planet's engine. How quickly would the molten iron solidify? What microscopic tremors would hint at this impossible event? Perhaps mirroring the seismic quiescence theorized for some rogue planets, drifting silently through space. With the core frozen, the first major catastrophe would be the magnetic field meltdown. Our planetary shield, the magnetosphere, would rapidly decay. The visual impact on technologies like GPS and satellite communication would be immediate and devastating, drawing stark comparisons to the unprotected surfaces of exoplanets without substantial magnetospheres. Next, a relentless cosmic ray bombardment would begin, illustrating the increased radiation reaching the surface and its implications for human health and electronics, drawing parallels to the harsh conditions on planets like WASP-12b, constantly blasted by its star's radiation. While beautiful, the potentially devastating and perpetual auroral displays would be a constant reminder of our lost protection, a spectacle more common and perhaps less threatening on gas giants like Jupiter, but catastrophic for a terrestrial world. As the core freezes, the engine driving our dynamic planet seizes up, unleashing geological havoc. Plate tectonics would grind to a halt. The absence of convection currents in the outer core would stop the engine driving earthquakes and volcanoes, but not without a final violent spasm, contrasting with the presumed stagnant lid tectonics, or lack thereof, on many rocky exoplanets. Cities once prone to seismic activity would become eerily still, and the bizarre geological consequences of a non-moving crust would unfold. A bizarre stability that might characterize the long-dead geology of an ancient exoplanet. Before true stillness, massive internal pressure shifts would cause unprecedented, short-lived, but cataclysmic quakes and ruptures, a final geological gasp unlike the ongoing slow processes seen on active worlds. With our magnetic shield gone and geological activity ceased, the next stage of destruction is the atmospheric apocalypse. Our protective atmosphere would begin to escape. The solar wind would begin to strip away our protective atmosphere, leading to a slow but inevitable loss of air, a process similar to what Mars experienced and what may happen to hot Jupiters or close-in exoplanets. This loss of atmosphere, combined with the absence of heat radiating from the core, would usher in the silent chill. Earth would gradually cool, turning into a colder, harsher environment, reminiscent of the frigid surfaces of rogue exoplanets far from any star. Speculating on how a dying atmosphere might affect weather patterns, leading to more extreme, localized atmospheric phenomena rather than global consistent changes, perhaps similar to the sparse, turbulent atmospheres seen on some exoplanets with extreme temperature differentials. As our planet transforms into a hostile, alien world, we witness life's last gasps. Ecosystems would collapse, portraying the domino effect on plant and animal life as radiation levels rise, temperatures drop, and geological stability vanishes, leading to an uninhabitable world similar to the vast majority of known exoplanets. Humanity's desperate measures would follow, exploring hypothetical last-ditch efforts to survive in a rapidly deteriorating world, from underground bunkers to radiation-shielded habitats, a struggle for existence that highlights the unique conditions required for life, conditions potentially absent on even habitable zone exoplanets without magnetic fields. The ultimate question. A reflective look at the profound fragility of our existence and what this impossible scenario truly teaches us about our planet's hidden power, making us appreciate Earth's delicate balance even more when compared to the sterile and lifeless nature of countless exoplanets.